All right, so I guess we can go ahead and get started. I'll spend a few moments talking about our level 1 fundamentals certification, which I would think that some or all of you may already have taken that certification exam. It's not a prerequisite to this cert exam, so don't worry about that if you have not completed the fundamental certification. And just as a disclaimer, this session will be recorded. We may post this to one of our video hubs. So do know that we are recording this just for future reference. All right, so today's certification, we used to call it level 2, where we are reworking our naming system for these different certifications. So now this one, known as the Search Mastery certification, focuses on the query language, how to use it, some of the more advanced operators and advanced use cases that we commonly see in Sumo. So we will be using a Sumo training environment for this. You won't have to use your own deployment. We will get to that info in a few minutes once we start the hands-on labs. But before that, I just wanted to review some of the basics. So the data flow that we have, data going into Sumo logic, that is how we ultimately arrive at the query language as our solution. So the demo that we have for that, I can, excuse me for a moment, I have to switch over to this demo account just for a brief intro into some of the different uses that we'll see here. So as we log into that, just take a moment to go over some of the items today. So as a part of the query language, if you have used it before, if you're familiar with our alerting system, then you know that an alert in Sumo is a scheduled search. So ultimately, alerts still depend on the query language as well. So this is our demo account. This is where we have some spoof data coming in to show off some use cases that we have. So Travel Logic is a demo application that we have. It's basically just a web application that allows you to go through the process of booking flights, car rentals, and hotels. And this is the Sumo monitoring solution for that. We have different dashboards showing different levels of insights here. This one focusing on the way the ELB is behaving, some of the other issues from Redis and the NoSQL databases. So this is the operational overview. We can also see into the services detail to see which of these different services between the flights, hotels, the types of bookings and where those errors occur. And this is all just a brief glimpse into what you can do with the query language and how you can use it to build out your own unique use cases. So here we can see that there was a spike in failures on the bookings end. So clearly there was a problem. There was some sort of application issue that occurred for this window of time because all of the bookings were failures. You don't see any successes during that time period. And I can use these panels to do drill downs to further investigate. This one here, driven by metrics, will allow me to investigate the different metrics that we're receiving from that application. Other dashboard panels powered by log queries, we can see the different error messages. So this is just a chart that we have, but we can also view the messages that aggregate it into those different figures. So the error messages that are occurring here, if I wanted to, I could read through every individual log message and identify what's causing this problem. So just at a glance, I'm seeing some Python errors here. Looking down at the bottom, client error access denied. So maybe there was some sort of authentication problem going on there. So with that information, I could then go and debug my Travel Logic application. That's just a quick glimpse into the value that we provide. So now we'll focus on the query language and how we're going to use it. We'll be going through some hands-on labs. So I will switch back over to the training environment for that, which unfortunately requires me to log out and log back in here. So do that. So all of the data that we saw, all of the different dashboard panels, the log messages that I drilled down into, those are the result of us ingesting data into Sumo. So that's step one. And we do have a separate webinar that covers Sumo collection. We call that setting up Sumo, because that is essential to getting started with the queries. Without the data, there is nothing to query, of course. But what we'll be focusing on more for today are steps 2 and 3 of this 3-step breakdown: the searching and analysis, and then also how to create alerts and dashboards to automate your critical events and to give you good visualizations into the type of information that you're seeing from those log messages. So the collection process in Sumo, there are multiple ways to collect data from any one source. Some are a little bit rigid in the integration that they provide with Sumo, but at the end of the day, if it's text, we will find a way to ingest it. That's what defines a log message to us, is a text log. And so if it's text, we'll find a way to get it into our service. And since we are cloud native, since we're hosted on the cloud, everything will ultimately go to the Sumo Logic endpoint shown here, the Sumo Logic Cloud. So all of your data is in a very centralized location. And as I go through this, I know I said something just right at the beginning of the session. Some of you may not have heard. There is a Q&A system. So if you have any questions and would like to ask those, feel free to post those in the Q&A. By default, these sessions mute all attendees just to reduce the background noise. But if you do have a question you'd like to ask out loud, you can also request to unmute and you can ask that question. I do want this to be interactive. I know that's tough in a virtual web seminar here, but if you do have questions, I would love to answer them and explore those use cases and examples. All right, so back to the Sumo process. I like this diagram just because it shows all of these different collection methods and shows that you can have all of these different services, because some businesses do have data across the spectrum from on-prem all the way up to very advanced cloud services. So we have to support collection for all of those different locations, all those different logging methods, and we do. But luckily, we don't have to worry about the details of the collection process today. So since we're using the training environment, all of that collection has been set up ahead of time, and we won't be exploring the collector configuration. But as a part of that data ingest setup, there are some metadata tags that are applied to the log messages. And these are mostly indicative of the logging process. So you can see the 5 metadata tags on screen here. We have the collector, which is just the name of the collector. This is a value that you're required to provide. So if you don't actually input anything there, it's just going to default to the host name. The source host is going to default to the same value, but is more likely to accurately depict the host name. The collector will usually be some sort of named value that indicates the type of collection or maybe the location. In some cases, it is best to keep it to the IP address of the box from which it's collecting, but we do see other values there. For our hosted collectors, we see values like AWS, the other cloud service providers like O365, Google Cloud. So that value is more user-defined, but it's more telling you where the data came from and how it was collected. Source host, mostly about the where. The source name tag is one that was originally created for file-based logging. So for on-prem logging of applications and Linux OS logging, things like that, we have the file path that will be shown as the value for that source name. So you can specify a single directory. You can look at just the error logs. If you want to look at the secure logs, all of those different values will be shown in that tag. The source name, similar to the collector name, this is one that we usually will provide that can be automated. Both of these can be built out as a part of an automation process. If you ever want to just quickly view the values of your collector and your source tags, you can look here on the collection page of your Sumo account. This page may not be visible to you. It's only visible to administrators by default, but we can see these are the collectors. So these are the names. If I open a query here, it's going to have that value collector equals ACS collector. But then we also have multiple sources, one or many sources for each different collector. So this ACS one pulling in Azure Blob Container data, as well as a number of HTTP sources as well. So these are the values of the source tag, the value of the collector tag shown here. For source host and source name, it's not shown on the collection page. It's usually shown, the best place to find it usually is in the log results themselves, where you can see on the messages, beneath each raw message result, there will be the host, the name, and the categories. So source host, source name, and source category. And that's our final metadata tag for discussion. The source category tag it's a foundational component of the Sumo queries that we write because it is optimized for good query performance. This tag has no default values. It's not going to automatically generate a source category structure for itself. If you create new data sources in Sumo, you have to apply values here. And we usually recommend a component-based nomenclature for that. So we'll show some examples as we go through that. Looking here on the collection page, you can see a lot of the values for source category, those shown here in the middle column. And you can see that there is this sort of hierarchy. There are different levels of the structure delimited by /, and they usually go from most broad, so largest, to most specific categories. As you step down into them, the data sets get smaller and more specific. So we'll be using source category as one of the driving factors for the scopes in the queries that we'll be writing. And we will get to the hands-on portion shortly. I believe that's what my next slide is going to introduce here, the hands-on exercises. All right. So let's take a few moments for everyone to get logged into the training environment. This is the link here. I will post this so that you don't have to type it manually. I'll copy this into the chat window. And I will do the same for the login information as well. So this to all attendees. There is the link. There is the username, and there is the password. So everyone will be using the same username and password, but it's not going to cause any problems. We've allowed for concurrent logins for this account. So in some occasions, there are backend troubles that we've experienced before. If that's the case, we also have a bunch of enumerated training users. I think there's something like 200 of them. So if we have to go that route, I can assign everyone their own, but hopefully Training Labs is working as expected today. So if you have any trouble with this, please let me know in the Q&A system or the chat window. Would also love if someone could just chime in that they were able to successfully log in, just so I know that things are going well. All right, thank you. Thanks, folks. Just wanted to make sure that I wasn't actually talking to an empty room, that everyone could hear me. But now that we're getting into the hands-on labs, hopefully we'll get a little bit more involved usage here. So when you log in, there's a certification tab that's anchored to the little home tab in the upper left of your content window. So looking on my screen, it's always going to be anchored here. We have this tab system very similar to Chrome's browser tab system. But here, the home one, always anchored there. It will never go away. And the sub tab from that certification. So the labs that we'll be using, the ones that we'll be doing as preparation for the exam are here, this link, the hands-on labs. This link you can follow here. And it will start with the training environment access, and then you can step through labs 1, 2, etc. I think we have, for this one, we have 23 labs. And there will be a little bit of repetitive material in these, so there will not be 23 fresh sets of queries to write. And a lot of the legwork will be done for you. They're not going to make you just manually type everything just for the sake of typing. So I will be using the slides to go along with these. We have some nice examples provided. So hopefully everyone is able to get to the hands-on labs easily enough. If you have multiple monitors, I would suggest maybe throwing the hands-on labs on your alternate screen so that they don't clutter your actual Sumo deployment usage. So we start off with the basics of search and parse. So searching the data, that's ultimately what we're going to be doing with all of these. That's what our big blue button over on the right side does, the start button, that is to start a search. So these are some example queries from some other virtual cert jam. I'm sure we can see someone was checking on root access here using our logReduce feature. So to begin, the searching, the scope is the beginning part of every Sumo query because it is the most important. So to start off, just looking at the scope. The best place to find some good example logs here in our training account, the Labs Apache logs that we have. We have both Apache Access and the error logs as well. So source category, the structure, the one that we have built here specific to training is usually going to provide most of the information we have right after the labs. So running a bit more broad of a query search there. We have quite a few source categories in here. We have over 100 that we have brought in. Different data types. You can see Palo Alto, Akamai CDN, lots of Windows logs, and the Apache Access. That's the one that I think most of the training labs are based around. So as you walk through those, you'll be exposed to different operators and the capabilities that they have within Sumo. So I always am a little conflicted about the best way for me to sort of guide you through these hands-on labs, because it's hard for me to know everyone's progress and if there are any questions or struggles. So if you do have any questions about how something's working, if it's not working, please let me know. The time allotment that we have for today, this is a 3-hour session. It's designed to have 2 hours worth of time for these hands-on labs and the educational material, and then an hour for the exam at the end. Usually in my experience, the exam doesn't take anywhere near that long. And since it is open book, open resource, open instructor, you're free to ask me questions during the exam. I would encourage you not to feel intimidated by it, because these walkthroughs that we have in combination with the support that we provide should allow you to find the answer to those exam questions. I took the Search Mastery exam. I guess I've taken it 3 or 4 times now. The first time I took it almost 2 years ago. I did find it to be pretty challenging. So if you do have questions, don't be afraid to ask. So I will continue stepping through some of the example material just to demonstrate it from my screen. So the searching and filtering, let me see if these slides can provide me some guidance. I'm used to just sort of shooting from the hip with my training material, so maybe I should actually try to follow my guided instructions. So labs 1 and 2 about search and parse. Searching, the scoping, I think I've already shown a few examples of that. Parsing is how you provide structure to your log messages. So there are multiple ways to parse, and we have a few different flavors of parsing that we can implement in Sumo. So this example here, oops, that is not the copy that I meant to select. The one that I have includes a regular expression parse. I'm sure there's one similar, if not identical, in the labs that you're using now. So regular expression, not a Sumo proprietary concept. We didn't invent regex. It's been around a lot longer than we have. The flavor that we use is PCRE, so the PHP version of regex. And you have to use named capture groups to apply the key to its value. So the IP address, we have the capture group here, but all of this held within this larger block with the name assigned at the beginning. So this format must be used in order to provide the keys and their values. If you just do a parse regex and you don't use this capture group, it doesn't really do any good. So with parse regex, there's the multi option. So if there is more than one example of if there are multiple IP addresses in one log message, then you can pull out all of those. And then for all parsing, including the anchor parse, which is one that we'll show in a moment, we also have the ability to modify our parses with this no drop clause. So no drop, by default, all of our parse statements are going to discard or drop any messages that don't match the parse pattern. So in this case, it's this IP address regular expression. So without it, if there is none, if it doesn't appear in the log message, then we don't get those results back. But if we add no drop, then it's going to increase the number of results that we get when there are non-matching parse statements within the log messages. Now, this example, there is an IP address in every single one of these. So this one, probably not the right example. Let me switch over to see if Palo Alto Networks, they've probably got one in every message as well, but we'll see. Here we go. So some of these that are coming through in a different format do not contain an IP address. So with no drop, we're seeing all of these that didn't match, but are still showing anyway. So they couldn't find an IP address because there was nothing to match this regex. But because we used no drop, those results were not discarded. So by applying this, we get less results, but only those that are matching. Here, if we look at the top 10 distribution, all these values are shown. If I add back this no drop, we will see this results count go up, and we will also see that there are blank messages as a part of this IP address field. So the number one most common value with no drop included is the empty string. And without it, none of those messages would be in this result set. So hopefully that was a clear explanation. No drop is an important clause if you know that there is some variability to the logs from which you're parsing. If the structure is not always uniform, then you may need to use no drop and multiple parse statements to capture the same field. All right, so after parsing, we have field extraction rules. Those are basically a way of applying a pre-parse statement to your Sumo account for a given scope. So if I wanted to parse out the IP address for all Apache messages, since it does appear to be there for all Apache messages, then I could take this query and convert this into a field extraction rule, which would take the parse statement and apply it to all newly ingested messages. So basically, that does the parse ahead of time for us to where we don't have to put it in our query at all, and it will still have the keys and their values shown. So here, IP, there is already a field extraction rule in place here that's pulling out these. It's just called IP instead of IP address. So if I go and look at the settings page here where the field extraction rules are, I'm sure I would find one that is pulling out that IP field. Now, I could not begin to guess who would have put that in place and named it. Oh, here we go. Extract Apache logs. So this looks to be the rule in place. which in this case, it's a funny one because it's using anchor parse, and it's also using the guaranteed position of the IP address at the beginning. But I suppose it works. So if I wanted to create my own field extraction rule, what I would do is to add a new one here. No, I'm not an admin in this account, so I don't think I have that option. But as a part of the rule, you'll give it a name, which doesn't matter. You don't have to use the rule name for anything. You give it a scope to tell it from which logs you want to parse these keys and their values. And then you give it the parse expression, which is going to evaluate the logs, identify the keys and their values, and attach those, sort of supplement those to the messages as you query them. So here with me, just running a source category labs Apache search, I will see that we still have that IP address field there because someone else has put that field extraction rule in place. So I don't have to run the parse. I get the value of having this field assigned up front. And as an added bonus, I can also use this in key value assertions, similar to how I used metadata for my scope. So here I have this metadata key and its value. I can also say IP equals some value there. So now I don't have to parse and then use the where operator to define that filtered statement there. I can put it directly into the scope of my search. So field extraction rules, they do have a limit for the number of fields that can be parsed or the number of rules in place. The limit for fields is 200 by default. So that usually gives most people enough room to work with. But if you were to hit that limit, we can increase it manually. It just requires a request to be made, and then someone on our end will address that. So if anybody has any questions about parsing, please let me know. I think we have some more examples below that. Yep, we have some that will show the other two primary parse types in the labs. So just to get a quick check, what lab number are people currently on? Just so I can try to keep the pace. All right. So moving along then to, all right, we have lab 1. So we're still getting started with the labs, so I'll make sure to not to move ahead too quickly. And I should probably go ahead and reopen that hands-on labs page here, just so I have a full view for what's being shown. All right, we have all the different scoping examples shown here. So it is important to understand the capability of scoping within Sumo and how important it is. So I mentioned earlier that scoping always comes first at the beginning of every Sumo query. And that's because it's the most important part of the query as far as performance is concerned. By limiting down to a small subset of data within the larger account before we take any action, before we perform any operations, that gives us much better performance than if we were to try to parse from every log in existence and then specify the ones that we care about. So scoping will always be the first part of your query. It's always the top line. And then the operators after that are separated by a pipe character. So in the scoping term, we have Boolean logic, but then as you get into parsing, as you look at lab 2, there is this pipe character that begins every operation except for the scope at the top. So that is what delimits one operator from the next. That's basically a logical separator for us, because the query language, it's evaluated in order sequentially rather than simultaneously. So it does matter what order you put those operators in. So the query syntax itself, hopefully the examples will allow you to become more familiar with that. Some important things to point out, things that are sometimes overlooked. We have basic commenting functions and other small little quirks within the Sumo UI. So 2 forward slashes is a single line comment. If you have a query that has a lot of, you have a query that has a lot of different operators in it and you're trying to debug that, then you can step down through those different queries. Oh, I'm still in the demo account. That explains a lot. You can comment out one line at a time from your queries. That's one of my preferred ways of debugging, actually, is to just take each operation, comment it out, basically nullify it, and see which one is causing the unexpected behavior. That's more what I was expecting. So with these different operations, comment these out one at a time. You can also do block comments /*. You have to make sure to end it or it will complain, even though it shows that it's commented out. If you don't put the end of the block comment in, then it's going to bark at you. All right, so some of the other parsing examples will be in the later labs, but before then we are already seeing an example of a count. So count by IP address, just to show how many log messages have come through with this value for their IP address. So I can sort this looking at the top 14 or the results we have here. But in this case, there's a filter that says only show me those where the count is less than 2,500. So this is actually looking at those that are less chatty, it would appear. So the filtering statement, the where, is just the application of Boolean logic. So anything that you put there, it's going to assert that it's true. And if it's not true for that given aggregate result or for that given log message, then that is also discarded from the result set. So with aggregates, as soon as you begin to aggregate your logs, you start to gain the ability towards charting. So just with the click of a button, you can take this table result, this IP address table here with the count. I can turn this into a bar, a column chart, a line chart, a pie chart here. We have a few more options, some of those only available under special conditions. But this now, just by aggregating, we can now put this into a nice visual representation. And aggregation is the prerequisite for dashboarding. So in order to create a dashboard panel, you have to aggregate the query. You have to pull it into the aggregates tab, which here is shown separate of the messages. So aggregates showing the result of this aggregation statement, but we still have the raw log messages available for view. All right, so we still have some folks that are working through the initial labs. I'm going to grab an example that I have here. I think this may be one of the lab questions. I'm skipping ahead a little bit. But in this one, we are now introducing a new type of parse called the anchor parse. And the anchor parse is a Sumo, it's basically a Sumo proprietary parse. It's a Sumo house blend. It's a way of parsing from plain text logs without having to write regex for wildcard statements. So here, we're simply parsing out the size field from these Apache access logs. That's one of the fields that comes through. For those that are familiar with Apache access logs, they always come through with all of their fields in order, separated by spaces. And so after the status code comes the size. So that 8,000 there, the 6,000 here, that's the field. We see that here, the size shown in this column as well. So that is then being summed here in this aggregation statement. They're summing the size, taking that numeric field and summing that by the IP address, which is what gives us our ultimate aggregate result, which is the IP address and how many total bytes they have sent or received. So the anchor parse, the star in that represents the size field. In anchor parses, you can break them down and have multiple different fields within one anchor parse statement, but they are mostly dependent on positional guarantees, dependent on the anchors that come around them. So in this case, the size field, we are ensuring that this wildcard captures the right value by looking at the 200 to the left of it, which is also going to filter out non-200s. And then we're making sure that there's a space, so 200 space some value, that's what the star just means, is anything that appears there up until it finds its next boundary, its next anchor on the right side, which is another space character. So because all of these fields are separated by spaces, we can easily use anchor parse to identify the fields, put a star in their place, and assign them a name. There's a UI tool to do this as well, and we'll walk through that in a moment. But I want to see if there are any questions about anything from the first two labs. Any Q&A stuff? Anybody got any questions they'd like answered about the initial searching, the parsing, anything about the query language itself? Feel free to let me know about those now. Otherwise, I will show my example of this UI anchor parse tool that we have. All right, well, I'm not seeing any questions in the Q&A system, so we can move right along then. So anchor parse, as a concept, you can see here that there is a parse statement represented in the query language. And when we use the UI tool, it's going to build a parse that it's going to add to our query. So I'm just going to deconstruct. I'm going to go back to just looking at the Apache Access logs. And now from here, what I'm going to do is I'm going to parse out the entirety of the log message. I'm going to select the whole thing, click and drag the cursor across the entire body of the message. And then I can right click on that. And there is a parse selected text option. And this opens up an anchor parse tool window. So this allows me to select the portions of the message that are variable, and I replace their value with a wildcard with just a simple star character, and then I assign that field a name down here. So this IP address, 46. whatever, that's going to be something different in a lot of these messages. There's a 128, there's a 70 there. So it's not always going to be this one value. That's a variable part of the message. So we call it IP. We replace it with the star. Anything that appears there will have this field name and whatever value falls in that position of the message. So then we have the timestamp here. So everything within the brackets, go ahead and call that timestamp. And then I can continue this process going down the entire log body. There's the method, click and drag across the get term, replace that with the star. So up next is URL. So this part of the message, the HTTP 1.1, that actually doesn't change. That's always going to say HTTP 1.1. So we're going to leave that. We have no need to extract that. So we just leave it where it is. The 503, that's a status code. So status is what we'll name that field. Up next, the size field that we had looked at earlier. And then after that, we have a couple of additional fields. I believe This one is the refer and then the user agent, or maybe the other way around. I always forget how that goes. I guess just for example, it doesn't really matter. We'll just assume it's refer, then user agent. All right. User agent. And this one, I'm actually not sure. This is new to me. I've got to go and do some reading about what this field is, what its purpose is. So F1, field 1. Don't know what it is. That's what I'll call it. So this is what I have ultimately deconstructed an Apache access message to look like. This is what they all look like when you take away the different values. And each of these stars represented by a name, so those values have an association there. Now by clicking submit, I will have added this parse statement to my query window. You can see it's done automatically. And if I run this query, I can see that all of these fields have their values extracted. They're all shown in their own column. Over here in the field display, I can see top 10 distributions of all of these. Just the get method that we're seeing. Here are the refers that we have, the different user agents. So it looks like I did get those right as far as refer versus user agent. Now that I've never seen before, that's a bit strange. Wonder if that's something from the training environment. And then these are the few URLs that people have been hitting for the for this service. All right, so I know that that example can be a little dense. It moves quickly. The UI tool can be a little tricky to use. You have to click and drag across those fields, then use the tooltip to assign those different wildcards. So does anyone have any questions about what I just did? Would you like for me to repeat it? If not, we'll just continue along with the material. So that's a part of the way that we parse, but the grouping and the filtering, the count and the where showed a brief example of those earlier. And then parsing options, also going to bring us to a new example showing the third primary type of parsing. So JSON formatted logs. I think they're fantastic because they provide structure in all cases. When a JSON message enters Sumo, it's going to be validated as a JSON object. So this is the text that we receive. And in some cases, it's single line format. It looks like CloudTrail even provides its own indentation, but sometimes it's all just jumbled together. But as long as it is a valid JSON object, not a single part of an array, but an object on its own, as long as it begins and ends with the correct notations, has all of the right formatting, then it's going to be prettified in the UI. Sorry, I'm just seeing there's a question over here. Let me finish this thought and then I will answer that really quickly. So JSON logs, because we have this nice guarantee of the key and value formatting, we can simply extract the values for any given key. So if I right click on event name here, then I can parse the selected key. Up here, it adds JSON field equals raw event name. So field equals raw underscore raw is this, the message, the raw log message. So it is actually not necessary when we're doing top level parsing. And I'll remove the auto just for effect so you can see that it's just focusing on the event name field. Now we have that name, we have the top 10 distribution of that, and we can see it very clearly corresponds with what's in the raw log message. All right, so take a quick divergence from this really quick. There is a question that I need to answer. The field extraction rules and the search. What if the source categories do not match? So with a query that you're writing, an ad hoc query that you type into the query box, something like the examples that we've been showing here. With those, most of the time, it's helpful to be specific with your source category. But in other cases, you may want to be broad to apply that scoping and the parsing itself to more logs. Now, with field extraction rules, it's actually not the best idea to be very broad with the scope on those. It's more useful to be specific and to have multiple very focused rules as opposed to a broad catch-all rule. The example that comes to mind most prominently is Windows event logging. Windows event logs, they're not always formatted the same for different event types. The structure of the message is always different. The order of the fields changes for each different event type. So with Windows event logging, instead of having one single rule that we use to catch all the different fields that come through with the different event types, I was hoping we might have an example here on our FER page. With Windows events, you want to build specific rules for each event type. So there's a base rule, which just captures the event code and the message summary. And then there are separate rules that you'll put in place for successful logins versus failed logins. And then other major event types that you want to capture and pre-parse, you'll have to build different rules for those. So here on the training page, so this one, because now I'm not in the demo environment, I do have the ability to create. You would put your scope in here, and then the parse expression goes below. And then all logs that fall within the scope would have this parse expression applied. So hopefully that helps to answer your question. I know I sort of rambled around the original topic a bit, but I did want to make sure to clarify a couple of those points. If that's not clear, then feel free to ask again. I know that the question just sort of disappears off the Q&A board there. But with field extraction rules, they're not ever going to drop logs. So as I mentioned with the parse behavior earlier, a regular parse in an ad hoc query will drop the non-matching results, but field extraction rules, they do not drop anything that doesn't match. So you don't have to worry about those filtering away from your initial data set. All right, so JSON auto, that was where we started it with the JSON parsing, and then I decided to show how you can do named key value parses as well. So you can have multiple keys parsed in one single statement. Now, that one, I don't know, I must have accidentally fat fingered the enter key there. So JSON event name, and then let's do user identity. That's a good one. So user identity, you can see here, it's just being shown, it's condensed. It itself is a JSON object, so it's a nested object. And as I parse that, I don't lose my JSON prettification. Now the user identity field's separate from the raw message. It's still here, but now we can see it on its own. I have the ability to break this open and see all of the different nested objects within this. So you can use dot notation to parse from nested fields. So if I only wanted to get the ARN from that, I could do a nested parse like that. So now we get the event name and the ARN from the user identity nested object. Parsing also supports nested parsing. So if I wanted to isolate this account number, or maybe the very end of this, I can break down the ARN and parse from that. Now, I usually prefer to do anchor parse for this because it tends to work pretty well for this type of situation. So let's see, star colon star slash star slash star as, let's see, we'll call this account ID. I'm sure there's probably just that numeric field on its own in here. So it's a different number. Here, the principal ID, that's what we're looking at there. But just as a proof of this exercise, we'll finish this one out. So after the account ID, oh wait, that was, let's do F1. Account ID, and then the other fields after that, component 1, component 2, component 3. Oh, look at that. Oh, I made a mistake here, and I'm not seeing the expected results. So C3 here doesn't just end with that account number. And that's because I forgot to make this a nested parse. So what I should have done is say field equals user identity.arn. And I usually don't use dot notation. I alias my field names because you have to use this %, double quote format, and I find that annoying. So usually I would just alias that. But here, now parsing just from that field, now that C3, that component doesn't bleed over, it now stops right at the end of just this portion. So since we're parsing from this finite string, we no longer get any bleed over from what happened after that. All right, so JSON auto, it's becoming, we're making improvements to JSON auto in the ways that it can be used. But here, I think this demonstrates what it does pretty clearly. Just by typing these two words, you will have parsed all fields from all nested levels of a JSON log message. So here, if we go and scroll through these, you can see there are some very granular fields that are being pulled out here. So it goes to every depth into every entry into an array. It pulls all of them out and shows them to you in the field display. There's a max depth that you can set as well, which will prevent it from doing that. I think it's max depth equals 1, max depth 1. Okay, no equals for that. And that at least will only parse the top level field. It only goes to the first level of depth, which is just this, the top level of the JSON object. All right, so I want to see how we're doing on the labs. Just a quick check to see what lab number folks are on. All right, seeing that we're done with lab 3. All right, so there's a few slides I want to point out just for educational purposes as far as the analytical capabilities you have. So similar to some programming languages, you have the ability to use logic to your advantage. So formatting options, conditionals, and then traditional aggregations, all available for use within the Sumo query language, as well as simple math operators. You can always do simple calculations. You can add numbers together. You can multiply, divide. I believe you can use exponents. Not sure about that one. I would have to double check. But hopefully you don't feel limited by the query language or limited by that. If you have any questions about the ways that it can be used to your advantage, just let me know. All right, so the labs pick up pace a little bit after the first few. There's a lot of examples in labs 1 through 3, trying to make sure that you're comfortable and understand what these operators are doing, exactly how they work, and when to use them, when not to use them. So once we get into the conditionals and beyond that, you'll start to see there's less hands-on material for you to use, but there are some some great operators and great use cases along the way. So for these labs, I'm going to step through these slides a little bit, try to make sure I call out some of the important parts. So lab 5 is one that's a sort of a new filter. This feature is basically, it's the fundamental, it's sort of a foundational piece that allows for correlation between logs in Sumo. Subqueries allow you to run a query within a query, one that can give you a specific set of results that the other one will then filter down to. So here in the labs, it starts with just the Apache Access scope and then builds out into this more involved example using the file does not exist. So I will go ahead and run through this example. I want to make sure to demonstrate this one. So this is basically just telling us the IP address that has the most file does not exist errors for this particular file, this USR htdocs file. So this piece of information can be passed along to another query. So the compose operator, in this case, it's compose IP. Compose is how you format your results to pass them out of an inner query to the outer query. So compose is a sort of an aggregation. It is considered an aggregate result. You can see here compose IP shows IP equals this values. If I also add keywords, then it removes the IP equals and just provides the value itself. So depending on the query that you're writing, you may use one or the other. So let's build this into a full subquery. We start with our parent query, and then we have to wrap our inner query in brackets. The brackets are the notation that we use to denote this subquery that's going to be occurring. And then you put the reserved word, a colon, and then the rest of the query will go in there, and then ended with that bracket there. So I can run it with this, and this will show me the Apache access logs that are correlated with these error logs in this IP address. So these 3,400 results, we look at the IP address, the source IP, it's just the one that came from our subquery, because that was an additional scope that we provided. Due to the location of this subquery within our larger query, this is treated as a scope. So subquery, the results that it generated that we saw before with just the IP address, that is basically just added up here as the IP. So now we're just seeing the Apache access results for those that match this full inner query and the composed results that were sent back from it. So this is a pretty advanced operator. I've seen some really cool use cases come out of people using subqueries. So it's very handy for security, and as you explore Sumo and as you become more comfortable with it, you may find some interesting use cases yourself for this. So this has been a long requested feature, one that allows for some of the basics of correlation. And so I thought it was important to make sure that we did demonstrate this one on its own. All right. So this one, Lab 5, relatively new in our search mastery certification here. And up next, we'll introduce the idea of plotting clients on a map. So we have the ability to pull geolocational information from a Mapbox lookup table that we have embedded in Sumo. And lookup is an operator that can be used outside of the geo function, we also have threat lookup, and you can build your own custom save and lookup tables. But this provides us with the ability to plot things on a map. And I don't know about y'all, but I really, really enjoy this nice interactive heat map that we have. It's just a lot of fun, even if it's only showing me some very broad locational information. Now, the Mapbox database is very, very accurate. When I said broad there, I didn't mean broad as in not being accurate location-wise, just that you know, a map itself is not all that actionable. It's really useful to have the specifics of the information. And with that, all you need in order to create the map chart, so this pin option from the aggregates result, this one is usually grayed out. In order to make this one accessible, you have to provide latitude and longitude. Those have to be the names of the fields. And so here, now that we have those, we can render this map. From this geolocation table, you also have access to a number of other fields. So here, you can see that I'm just being lazy and copying them from our dropdown. But country name, region, city, there's even country code. I like that one because it's handy to use for quick tables. So now instead of looking at all this on a map, want me to copy this down into the aggregation. And now, instead of just seeing coordinates, we can see the name of the city, the country from which these attacks came. Our old locational table had state information. This one has region instead, I guess because other countries don't have a state, but we do still show the cities within the US and the region that they're in. You can see here for this one in France, there's some regional information. So now, if you were more interested in identifying the cities or the countries from which malicious events are occurring, you can do that. A query, an alert that I've built for a customer before involved taking a list of all of the US embargoed countries, the countries we don't trade with, such as North Korea, Iraq, countries like that. There's a list of them, and there's also a list of 2-letter country codes that are used as a standard. And so I built an alert that would notify them if they saw any activity from any of the country codes listed on that embargoed list. So geo information can be used. You can use that to quickly identify if a foreign actor is moving against you, making threats or attempting to infiltrate your network. All right, that was a little bit of a deviation from the geo lookup that we had here, the nice handy map. Since we still have latitude and longitude as a part of that count, I can still render this map. It's just that the table now has increased value because we can see a little bit further into the different locations that are on that map. All right, so just moving along quickly then, there's some optional stuff here in the labs as far as testing your knowledge. Here, this one wants you to build a time-sliced example using the time-slice aggregation. So that one is very helpful for bucketing information, for bucketing events into specific windows of time, which is especially useful for histograms and for outlier detection. So what I'm going to do is I'm going to basically just break this back down, time slice, 1 minute, going to increase this to a 1-hour time range, and then just do a very basic count time slice. Same as count by time slice, the by not really necessary. So now in table view, I have every minute in time for the last hour, and the number of log messages I received during those those 1-hour windows. So a line chart and a fill chart, these become very attractive options since the x-axis is now representing time. So from a little while ago until recently, I can see all the log counts. Now just counting by time slice is great, but it's not actually any different than the histogram shown above. Unless you've filtered these in some way, if you're just doing a count by time slice, these are the exact same thing. You can see here they're even the same size time bucket in this case. The histogram automatically chooses its bucket size, and here I just chose one that happened to coincide with that. But where this gets interesting is that now that we have a time series, we can now begin to detect outliers from that. So the outlier reserved word must be supplied with a time series. And as long as you give it that, it will draw up a threshold and a window. And now we have notifications of points in time where the norm was exceeded, where the threshold was violated. So you can supply it any type of time series. If I wanted to add the word error here, if I wanted to just detect a spike in errors, then I could do that. The outlier operator has a lot of custom tuning that you can do. There is direction. If you only care about spikes and not dips, then you can do direction equals plus. There's the window itself, which is by default 10 trailing data points. You can shorten that or extend it if you like. The threshold itself set to 3.0 standard deviations by default. You can change that floating point. You can reduce that threshold. So if I reduce the threshold and change it to direction equals plus, now we're being shown a few spikes here, but this one dip where it went below is not being shown as part of the marked results. So that red triangle indicating that it is an outlier and one that matches the conditions provided. So outliers are a great way of building real-time alerts, or not real-time alerts rather, but good adaptive alerts that account for recent changes in volume and recent changes in count. Using them, you now have a more clear way of determining what's an outlier. So looking at this visual representation, you can see the red triangle, but here on this table view, there's actually a key and a value that correspond with that, and that's count violation equals 1. So if I wanted to build an alert for this, if I wanted to add the word error up here, let's see if this breaks it. Yeah, unfortunately, now I got to do Apache error. Hopefully it still works. Yeah, look at that. That's good enough. So now we're looking just for error messages and a spike in those, and I want to be notified when that spike occurs. So I don't want to just look at a graph. I want it to automatically tell me when that happens. And so what I add here is a filter that says where count violation, which is the name of that column. Again, if I go back here, count violation, this is the column that is, it's a Boolean column, 0 for no, 1 for yes. So where count violation equals 1. That basically says, draw the outlier chart and then tell me all of the points that are outliers. So here, 133, 147, 149. If I comment this line out and go back and look at my original chart, I will see, yep, these are the points that were shown on the table. So it's very easy to take a regular query, just an ad hoc query that you use for observation, and turn it into an alert just by adding a good filter, by saying where some threshold has been exceeded, where some weekly maximum has been exceeded, something like that. And then you begin the process of scheduling the search and turning it into an alert. So I think that occurs later in the labs. I'm going to, should I do that now? Let me see what my lab order says. Alerts are down near the bottom. Let's go ahead and do it anyway, though. I like my outlier example. I think it's pretty clear how this becomes a useful alert. So in this case, we would want to keep it in table view. We don't really benefit from this line chart. The window and the threshold are broken because we've removed too many data points. So now all these series are being shown in just a visual line view there. But what we really care about are these points in time, the actual times when these spikes occurred. And I would, if I were investigating this, trying to solve a problem, would go and run queries specific to these 1 minute windows in time to see what's causing those errors and what I can do to fix it. All right, so let's create that alert. The first thing you have to do in order to create an alert is you have to save the query. It has to be saved somewhere within your content structure in order for it to exist as a scheduled search. So error spike Apache example. Not my best name, but it'll work for now. So I'll save the search, but you may have noticed there was a button in the bottom left of that save window, the same button that's shown here in the bottom left of the edit window, schedule this search. And this is very important because there's a lot of initial confusion. For new users, there is a lot of confusion about where alerts are created, how do you create them, and how do you manage them. And that's because our process is a little bit indirect, I would say. It's not the most intuitive for a new user. You have to create and save the query, and then you have to edit it, or using the save as, you go to schedule this search. And the schedule is what determines the alerting notification. This is what determines the frequency of the query, how often it runs, what time range it runs for, when do I actually notify people. You can create a report that will tell you even if it doesn't find any results. But in our case, since we've added that count violation to our query, since we've given it good, clear alerting conditions in the query language itself, all we really need to tell it here is that if there's more than 0 results, then we want to be notified. And how we choose to be notified is the last of the major conditions here, that and who is a part of that. So email is the default option. You can send to distros, to individuals, you can do comma separated lists. But we also have other notification types. So webhook integrations are very common. The Slack webhook channels, HipChat. I'm not exactly sure what SK is, so there must be some Slack channels specific for a different training exercise, and there's a mixed panel. So anything that has the option for a webhook connection, you can build a custom notification and send these notifications across through those channels. I've built one for Microsoft Teams before. I've built one for random services like that, where you're basically just sending along the information that something occurred in Sumo, and in some cases, there's an automated response to that. So for now, what I'm just going to do, just to show how the alert works as far as what changes in the UI when it's scheduled, I'll go ahead and save this. So that's just having it send to me. And since it only runs once an hour, it's probably not going to fire it anyway. But now that I've saved this and scheduled it, looking into my personal content tab where all of my queries reside, all of my content, there is an error spike Apache example. This is the query I saved, and there's a calendar icon shown next to it. So ordinarily, you just see the 3-line icon, this ubiquitous icon that we use everywhere in Sumo to show log search. But the calendar indicates this search is on a schedule, aka it's an alert. So those terms are synonymous. A scheduled search is a log alert. So there is a menu for alerts under manage data. This is for metrics alerts or metrics monitors. I have been saying that they need to rename this for a very long time now, and unfortunately I just don't seem to get any traction there. But don't confuse the two. Metrics alerts are separate from log alerts. Logs are what most people are spending the majority of their time searching against and searching through. And so if we automate the log process, the log alerting, we can save a lot of legwork there. All right, so I'm going to unschedule my search so that I don't get a bunch of strange emails. All I have to do in order to get rid of the scheduled part of the search and turn it back into a regular query is just put the frequency back to never and click update. So now it's just a search again. It's not a scheduled search. It's not going to run on its own. It's not going to send to anybody any notifications. So that's that's the basics of how to create, schedule, modify, and remove an alert. All right, so jumping back into some of the lab content. I'll try to speed through some of this. We only have 40 minutes until it's time for us to do our exam, so I will try to make good use of this time. So formatting the results, this transpose example, I do like this one because transposing, from my understanding, it's also a common feature in Excel. I am admittedly Excel illiterate, so I find myself fortunate that I don't have to know how to transpose in Excel. But in Sumo, if you attempt to aggregate by more than one dimension, if I count by time slice and status code, it works on a table view. For this time period, status code, this is the count. So I could scroll down and look at all of these, but the times are out of order here. The status codes are out of order. It doesn't know how to serialize two pieces of information that have been used in one dimension. So if we look at a line chart, on the x-axis, we have status code by time slice. Basically, it's both of those, and it can't serialize them. It doesn't know how to order them properly, so it just creates a big jumbled mess. And that's where transpose comes in. That's where it saves the day. Now we're saying row is time slice, so keep time on the x-axis. That's where it belongs for us. And then the column, split out the individual counts into their own series for the different status codes. So this is the 200 count, way above the rest, which is where we'd like to see it. And then down here, the second most common is 304. There's some other smaller values there. If I wanted to, I could switch this. Oops, not that one. Change, what is it, axis? Yeah, change axis to logarithmic scale. Now I can see this on powers of 10 and can see these smaller counts that are cluttered together down here on the linear chart. All right, so moving quickly along then, transpose, great for creating good dashboard panels and visualizations. I personally have not had a lot of success using it in other advanced use cases, but that could just be me. All right, so changes, moving averages, use of the diff operator. So I'm sure everyone has, if you're taking the labs, if you're following along, I'm sure you're copying and pasting these queries into your training deployment as well. So as I look at these, you can see the diff that we have down here. So diff is a very finicky operator here, or actually I think in that case, it's just because in a lot of these, it's negative, and so we're not seeing it down there on the bottom end. If I were to change this, I could put in maximum 5,000, leave that as is. Didn't get it to redraw for me. All right, well, I don't want to spend too much time on that, but the diff operator is working correctly, but the visualization a little tough because a lot of those numbers are negative, so they're not shown by our default rendering that we have there. Now this one looks a little better. This is our fill chart that's showing the diff all the way down here. Someone pointed out that log scales don't allow for negatives, which is a great point. If I had forgotten to switch that one back, that definitely would have been part of my problem. But here, it's like we're on the linear scale. All right, so diff, there's also the smooth. You can sort of see the trend as it is there. I have, in my experience, found the predict operator, which I think is just a little bit ahead here. I like that one. I don't use smooth as much myself. I guess the examples, the use cases that I get called into don't involve that type of insight as frequently. So Lab 9 is focused on logReduce, which is one of our big features here at Sumo. It's something that we offer that none of our competitors do. It's a signature analysis tool. It breaks down your log messages by their structure. It's similar in concept to an anchor parse, actually, but sort of doing the opposite. Instead of finding all the different values that come through in the different fields, it's actually just going to wipe away the variability in favor of consistent structure. So let me show an example of that. I think there were a couple that were open here in my account as I was exploring earlier. If not, I will just run my own because it's very easy to demonstrate. All right, so we'll just borrow from this query window. Error. It's a nice, easy scope. If you don't know where the error occurred, if you're not sure which service caused it, it's a great scope just to try to get your bearings and understand where the error is. So here, there are 42 different source categories, training, travel, checkout, that travel logic demo app causing the most. And then we also have a number of other services that are logging errors here. So there are 17,000 messages in a 15-minute span. That is unmanageable for any one person or small group of people to sift through. I wouldn't want to do it personally. So logReduce allows us to, it is in a sense an aggregation. It is grouping these messages together, but it's doing so based on the signature of the message, the structure. So now instead of seeing individual results, we now have signatures grouped by their count and sorted by their count. So by default, it sorts by most frequent down to least frequent. So we can see these are the types of error messages that are occurring. The stars have wiped away all of the different variable parts of the message so that they could be joined together in these signatures. And with this, you can then look for specific formats that you know are in line with the problem that you're experiencing. You may just want to reverse the count and look at these messages here that are in the one-off section, those that were too different to be grouped with anything else. So some of these messages may hold the key because they were obviously so different from normal behavior that they didn't match the signature. And then there's the actions that you can take to try to provide feedback, to try to help it help you. So the thumbs up and the thumbs down that you can provide here to give it feedback to try to help it determine what it is you're looking for. So if I know that I don't care about any of these checkout process logs, so that's obviously travel logic doing something, but let's say that there's something else going on that I'm trying to identify. It thumbs down those messages that contain this similar structure where I can see the checkout stuff, the travel logic information very clearly displayed. And if I was looking for JSON messages, if I knew there was something in there, then I could thumbs up the JSON results and then sort by relevance and see if it can help me determine the ones that I care about. So logReduce, very powerful tool, does allow for quickly identifying problems within data sets. And one of the options shown here, this time window setting that you have here, if you've identified something within one of these groups, so let's just randomly pick one here. So this is a group of 19 messages. By clicking on the count, I open up this search that only includes those messages, only these 19. And I can then take this and further investigate what happened at either the source host, the source name, or the source category level. So if I knew it was this particular host that was causing problems, I could go look at the surrounding messages on anywhere from a 2 to a 20-minute window, plus or minus 1 to 10 there, allow you to go and then see the surrounding messages. So anything that may have caused a cascading failure or anything else that happens as a result of that failure. So a question about the feedback from the logReduce. So that feedback is user specific. It does not apply to everyone in the org. And you can actually roll back those changes using the undo and the redo buttons that are available. So here on search 13. So if I wanted to take away the changes that I made, I can click this button and it will step back and stop applying the thumbs up and thumbs down. It reverts those changes. So no, does not apply to everyone in the org. It's user specific, and there is some degree of session life cycle to it. I'm not exactly sure how that works, but it does have some memory of your former actions. But then if I saw something in here and I couldn't undo it, I could just simply click that to remove that feedback that had been given. All right, so after logReduce, there's logCompare. So logCompare allows us to make temporal comparisons or other comparisons between different signatures of data. So it's going to be based on logReduce. It's still going to do the signature count, but what it's also going to do is it's going to compare the signatures against some other log set. So by default, it just chooses a past window. If I just click the button, it goes back 1 day, compares against them. And now for the count, we have the number and we also have the percentage changes. So I can see there are 30% more of these messages than there were for this 15-minute window yesterday. So plus 30%, great way to keep an eye on that. And if the messages didn't appear at all yesterday and they are appearing today, so there's a gone if they appeared yesterday and are no longer present. And then there's also a new. So some of these didn't appear yesterday and have appeared today. So those are new. So that's another way to help identify problems and abnormalities in behavior. And on top of being able to compare against different time periods, you can actually compare against different data sets entirely. So if you had two hosts, two machines, one of them was working fine and the other one is just going haywire, you don't know why, then you could come in here and say host equals A, and then come over here and say host equals B, and that would still work. That's valid for the logCompare. So logCompare is a very useful tool for trying to identify those changes in normal behavior and point them out. So here, identify out of the ordinary events. This is the outlier example, the one I demonstrated previously, which we also converted into an alert. So I am going to skip over demonstrating this one again. You've got a sample query here if you would like to use that. And then identify future trends. I believe this is going to be for the predict operator. Yep. So this one I have found to be useful before. We have this one in use on our data volume dashboard to predict future ingest. So here we can see this. So the light blue line, that is our error count. And then this line, this very, very straight line is our error count predicted. Now, I prefer to use the autoregressive model, model equals AR. In this case, it says it doesn't have enough data. I guess I would have to stretch this one out to be longer than 15 minutes. So that gives us better info. It says, we'll train a better model with more data points, but now it's at least showing us this is the predicted error count on an autoregressive model. So there's a question in Q&A about, can you sort the logCompare count by the percentages? I don't believe you can, unfortunately. As far as the percentage in change that comes along with that, I'm guessing is what was meant by that. Now let me double check to make sure that I'm not forgetting about a key name for that. I know that there are some additional fields that are introduced behind the scenes. I'm checking right now just to see if there's anything that we can leverage there. All right, so we have the signature ID, raw with no date. All right, I don't think I see anything that allows us to sort by percentage, unfortunately. But if I do find out any information on the contrary, then I will let you know before this session ends. I'll make sure to check around for that. All right, so LogCompare, a great tool for identifying those abnormalities. And so the future trend, the predict operator, similar to outlier in that it requires a time series, of course. Otherwise, it doesn't really know what it's trying to predict, because if it's not looking in the past, how can it know what to look at in the future? All right, lab 13, the transaction operator. This one is pretty advanced, but it allows us to apply a sort of a state diagram to our logs and the results that come from them. So within a single set of logs, we have the ability to link them. So here we are using the IP address, we're transactioning on that, and then we're following that IP address as it goes through, as it detects these strings in different log messages. So it's going to group the IPs together. You can see the group IDs here coincide with the IPs and their numbers there. And then you can see the different transition from one state to another, where it went from there to there, shipping info to shipping info, cart to shipping info, etc. So this example, a little limited, but it does show how we can do that. So this one is a little bit more of a good visualization, shows the flow diagram option that we have, the Sankey charts. So here, this is one of the charting options that's only available with very specific formatting in your query. And in this case, the formatting that's required, you have to use the from state and the to state. You have to count by those after assigning all of these states and doing a result by flow. So that shows us the bulk of the requests go from cart to shipping info, and very few go beyond that to confirmation and or order shipped. So we can actually see some information about the numbers here. 279 that transition from cart to shipping info, but then 4 that get from there beyond, 2 that go directly to order shipped. So transaction, very, very advanced. The Sankey charts, they're really helpful in identifying failures in process for web applications and things like that. For our example, I think it's pretty clear to see how that would be useful in seeing that there's a huge drop-off in this transition here. So that to me would indicate there's a problem with what's occurring as a part of that transition. All right, so we've got a few labs on metrics, and looks like we're doing all right on time here as well. So that's good to see. So metrics in Sumo, I think I opened up a metrics query earlier as a part of one of the dashboards that I was showing. Metrics are treated separately from logs in Sumo because conceptually they are a different thing. So a log is a piece of text, like I mentioned earlier, and a metric is a numeric series with some sort of text tag. So something just posted in the chat about the percentage sorted question. Delta percentage, it appears, is one of the fields that we created as a result of the LogCompare. So let's go and check that out. Just jump back to one of my recent ones. Error logReduce, compare with time shift. So that that delta percentage would be one of those Sumo fields that not able to be seen. So I think the chat messages, I'm not sure if they are visible from one attendee to another. It says to all panelists on there. So I'm going to go ahead and post that from my end. And then we'll go ahead and check on that as well. So where delta percentage greater than, let's do 20. Since it hasn't complained to me yet, I would assume that means it's working as expected. So 2023, there were some 19s and some others that I saw in there before. Scrolling quickly, it would appear that it has worked. So the new tag, thank you very much, Lawrence, for posting that. I'm just going to repost it because for some reason the chat system is very weird in Zoom. So to make sure it goes to all attendees, I just copy pasted that. So sorting by the delta percentage, if you look in the chat window, there's the example there. I will copy and paste it up here into my presenter screen. And I really appreciate you taking the time to find that, Lawrence. That was very helpful. I know there's a lot of those underscore prefixed fields that come through when we do these automatic calculations. If we look at outlier, we see all of the count upper and lower and the differences and those values there. So delta percentage is the name of that one here. And the underscore prefix, just for clarification, that indicates that a field was created by some sort of internal Sumo process. All of our metadata tags begin with it. All of the automatic field generations will have this underscore prefix to differentiate them from user-created fields. So when you name a field, it is not necessary and not recommended to put that underscore prefix there, because then it's harder to tell the difference between your fields and Sumo's fields. All right, so moving back to our metrics basics. So just looking at the beginning of metrics, we have type bookings metric equals success count. So we do have some autocomplete as a part of the metrics query language. It's not perfect. It helps you to understand some of the tags that you can use for scoping. But to me, I don't find it to be very useful with the operators. They don't, I feel like the autocomplete does fall a little bit short there. But there is some additional functionality that we have here that I think is pretty cool. And that's the ability to combine these. So if I wanted to, just to get a rough guess for the percentages of errors that are occurring, I could do success and fail. And since fail, it looks like is always 0, I did fail divided by success because I didn't want to get a divide by 0 error. But now if I were to look here, if I go to my legend, which looks like I've got a UI bug from that Sankey chart. Now we'll see the one at the bottom. I believe that's the one that I've just created there. No, that's just the collector. Sorry, let me do a page refresh here so I can get rid of that stale tooltip. But basically, you have the ability to then combine metric series however you see fit. So you can click to enable and disable them. I can just turn off the fail count just by clicking over here. And you can also overlay log queries with this. They're not the full log capabilities that you might expect, but let's just do travel. I think that'll pick up travel logic. And then error. So maybe that wasn't a good one. We'll just do Apache. So now we have a density chart that shows over the top of our metric series. So if we were tracking something like the error rate, which this is success and fail count, not totally relevant, but you can overlay log queries onto the metrics display. And sometimes that will quickly show you that there's something going on in the log messages that correlates with a rapid change in metrics and some sort of unexpected behavior. So the outliers are built into the metric series. This pink dot here is for outliers. They will automatically show up. It looks like you can make some small changes here. So if I reduce the threshold, then now we have one outlier there. Okay, so these are all different standard deviation multiples. So that's one standard deviation. This is 7. So the metrics query language, not as advanced as the log query language. There's not as much that you have to do with the time series number. Just not as much information to extract, as much insight to gain from that. But there is the ability to turn a log into a metric. So if you have log messages that are sending some sort of number through, and it makes more sense to track that number with the metrics charting than it does to have to aggregate it down into a query and then choose a chart and keep that chart up to date. If that's not worth the effort, if it just doesn't make sense, then you have the option under these settings to use logs to metrics. So here you can create a new metric series from your log messages. So let me take one of Mario's examples here, looking at the 404s that are coming through from Apache. What he's done is he's taken the Apache access logs and he's pulling out the IP address. He's pulling out it looks like he's pulling out all the fields that we usually see for Apache access logs. And then we are seeing what the preview of that would be. He's then chosen down here to use the size as a metric field. So that will be coming through as a measurement. And the dimension for that is going to be the status code. So we'll see different series for each status code. And those will come through as metrics, be counted as such. So no more need for log querying against those. So logs to metrics, currently it does not support any sort of aggregation, which means that if you created a logs to metrics source for a very noisy log source, then you would get a lot of metrics DPM usage. So be careful with that. I would expect future iterations of this feature. This is still pretty new. I would expect them in the future to offer some sort of temporal aggregation. So that way you're not exceeding your metrics ingest just by pulling in one log to metric source. All right, so up next for metrics, time shifting. So this is actually something you can do with aggregation as well. I don't think I touched on that as its own topic, but anytime you aggregate, if I can jump to one of these examples that has one, I'll just pull one up. So anytime you're aggregating, there's a time compare option here, and you can compare against some window of time in the past. So that also applies for metrics as well. So if I come here, let's go ahead and just, did I copy that from the wrong place? Yep. So there's that. And we'll turn off these so they don't get in our way. So the latency, the mean latency on its own. Oh, it looks like maybe my comments don't work here. So we should expect to see something, I guess for me personally, I would think this number is a bit high, seeing that it's in the hundreds for the latency there, but also having the ability to time shift that as well. Yes, so with this, it has actually drawn the time shifted 1 day metric latency, but what it did was it just drew that. So with log aggregation, it will automatically render the initial aggregation as well as the time shifted one. For metrics, it looks like you have to have both series displayed on their own. It's not going to run today's mean latency and then also overlay it with yesterday's as well. So that's slightly different from the log time compare, but at the end of the day, we get the same result. We now have these two series and you can compare them quite easily. All right, so assuming we'll have some delta here, yep, so the delta operator that you can put in place for these different series. So we'll do packets received, turn these off. And so I'm just disabling these series and I could re-enable them at any time. Now here's where I will have to get a refresher on whether or not these are going to duplicate. And it looks like I may have run out of my limit of series here. All right. So the delta, the rate, these operators allow you to just get a better understanding for the changes in your metrics. So as is pointed out here, identifying an outlier on a rate of change is a better indicator of a problem than just identifying an outlier itself. If you notice there's a spike in the rate of change, then that indicates that the number is going to continue to go up or down, and your problem will probably continue to get worse. So looking at the rate, staying pretty low and pretty uniform for this number that we're seeing. So this is not making any dramatic swings in either direction. We see that this rate stays fairly flat. All right, so relating metrics and logs, that's what's next. I think that's more or less just an example of what I showed before, where you have the different bookings and then you overlay that with the error count. So let me see if I can get this exactly as depicted in the docs. Training, travel, checkout. All right, so that's a little bit closer to what I would have wanted to see. I'll delete some of these so we get some of our screen real estate back. So now we have the success count and the fail count. And from just this source category, just from the travel checkout portion of the app, we're seeing error messages that seem to correspond pretty accurately with the spikes in failures that we're seeing. So again, just a more accurate version of the overlay that I showed before. Now we're just seeing the checkout errors. You can click on this time slice, it shows the log messages here. So quick insight into those messages that are affecting your metric series. All right, so we've just got a few minutes left before it's time to begin our exam. So the last few labs, dashboarding and how to use them, as well as the applications in Sumo, how to install those. So I touched earlier on the prerequisite for dashboarding. So just to go back to that, we'll pull up my recently run example that just has my count with the where count. So now that I've aggregated, I can add to dashboard. And to create a new dashboard, this is also something that's a little confusing. You have to start with a panel, and then you add that panel to a dashboard, and then you type in the name of a dashboard that doesn't exist yet, so new dash. So it evaluates to see if that's in the list. It's not. I can click on this option, new dash, and then create my new panel on my new dashboard. And as I do this, it opens up a new tab here with my new dashboard and my new panel. It opens it in edit mode. I can reposition, resize this dashboard panel. I can toggle it into a dark theme. I can add filters. I can do all sorts of things here. And then to add more panels to it, you write the query, you aggregate it, and then you click that Add to Dashboard button. That's the procedure for building dashboards currently. We are going to change that process to make it to where you can start with a blank new dashboard soon, but I'm not exactly sure on the timing of that release. So for now, we'll just continue to use this way, and it starts with a panel. All right, so publishing a dashboard, the other part of this exercise here. So if you want to share a dashboard, you can do so with the share button. It's similar to content sharing in Sumo in other ways. This is how you would share a folder of content or an individual query. You have the different levels of sharing that you can use here. You can select individual users, you can select roles, you can select everyone. But dashboards have an option that other pieces of content don't have, and that's the ability to be shared outside of your Sumo org. So you can make this accessible outside the org, and you can either choose an IP address whitelist from which everyone must reside, otherwise they can't see it, or you can make it world visible where anyone that has the link can see the dashboard. For obvious reasons, we recommend whitelist over world visibility, but world is an option there if you just need to make the dashboard accessible to a large group quickly. So saving this would enable outside access from people within the whitelist. I'm not going to do that for now. If I did, there would be a little globe icon represented up here to indicate this is shared externally outside of my Sumo org. All right, so last few things about dashboards, and then we will set aside that hour for our test. So adding panels to dashboard, hopefully that's well understood. You basically just, as I said, you create the query, the panel itself, and then you add it to a dashboard. So adding the exact same panel to my new dash, and it's already got that name. So this here, just me showing how to add those to the dashboard. These are essentially the same panel, just with different visualizations. So once I'm toggled out of edit mode, that then allows me to modify the results that I'm seeing. So here, this top IP address, if I want to remove that from the list or from the pie chart, I click and it's gone. So this is interactive mode. I can interact with the dashboard panels. I can scroll up and down in this list. But then when I toggle edit mode, everything becomes about maintenance, moving, resizing, etc. Deleting panels accomplished just by clicking the X up here. This is the master time panel. This is where you can control all dashboard panels from a single location. If you wanted to have all of them set to the same time range to do a quick search, this is how you would do that. By default, dashboard panels are allowed their own time ranges. You can have 20 different dashboard panels with 20 different time ranges. But if you ever needed to quickly snap them to a different period of time, this master time panel is the way to do that. A couple more things. Live mode toggled here. Dashboards in live mode are not interactive. You can't click into them or drill down or do anything with them. When you share a dashboard externally, it's automatically converted into live mode so that anyone that does see it is not able to drill down or interact with it. You can do a manual refresh of your dashboard by clicking the refresh button here. All you have to do is just click it and you should see all of your panels re-render. And then the filters, one of the last options here. There are recommended filters at the top of the list. Those are the fields that are being used within your panels most frequently. Then there are also others, which are just fields that have been parsed at some point by some of the log messages within this search scope, within this dashboard scope. So here, obviously, I could put in an IP address one if I wanted to filter to just one. Since that's all I've got here on my dashboard, that would do me a lot of good. I could choose any of these other fields as filters. And by default, it's going to automatically link to every dashboard that has that field. So IP address exists in both. If I mouse over this blue funnel icon, I see that both panels are highlighted. Both will be affected by this filter. So now, if I were to copy this value into here and then run this, I think you know what to expect. There's a donut here, it's one full pie chart and just one IP address. These do allow for wildcarding, so I could do 78 star. See if anything else comes through, just the one still. That is an option. Dashboard filters are a very powerful tool for taking a broad dashboard, something that has a very high level overview, and then zeroing in on something specific very quickly. All right, so it's just now reaching the top of the hour. Let's take a short break. I'm going to take a bio break, and then we will have our hour allotted for the test. I'll be here to answer any questions. I'll be back in just a moment. All right, so last couple of labs here. I'll touch on these as we move into our test time. Create meaningful alerts. This one, just ensuring that you understand the best way to identify good alertable conditions. So this one, very similar to the outlier alert example I showed before. In this one, they're identifying this failure rate percent indicator as the number that they want to monitor. So similar to mine, where outlier violation equals 1, this one indicator greater than 0. And then this one here, using the data volume index to monitor for when your ingest reaches a certain percentage. So the data volume app is a great way to understand your ingest in Sumo and can be found in the app catalog, which I believe is our last lab, is how to install an app. So all of what we've done today, as far as typing out queries, or rather copy pasting them from my end, all of that, a lot of that work rather, can be prevented, or you can find ways around that by using pre-built content. The app catalog is a collection of queries, dashboards, alerts that are designed for each different data set. So there are some very popular names on this list. You see a lot of AWS services here at the top, Active Directory from Microsoft, Akamai Cloud Monitor, the list goes on. There's a lot going on here. And all of these, an application in the Sumo context is a collection of queries and dashboards that have been verified to work against these data sources. So for what we were looking at today, Apache, we have pre-built queries, dashboards that you can install, and they work out of the box. All you have to do is install them and open them, and they will show you the results for those queries and those dashboards. So for those that are looking ahead to lab 23, that's how you would do that, is just search for Apache and install that one, and check out all the cool stuff that it gives you. For lab 22, alerting when data ingest goes above 50%, there's a data volume app, and this is for tracking data volume. So I actually have this one installed already, so I can go over here and open daily plan limit. This is a pre-built query that is designed to tell you if you've exceeded your daily ingest. The only thing you have to change here is this 1. So that's just the default number we put in place for 1 gigabyte per day. So here our training environment has ingested 47.5 gigs. in a daily period. So that was for yesterday from midnight to midnight. So that's more than one. But if I wanted to set it at half of my allotted ingest, I could go to my account page, determine allotted ingest is 400 gigs a day, and then change this to 200 because that would be 50% of my 400 gig allotment. And then what I do down here, or I don't even have to add a where because it's already been added here. All I have to then do is schedule this to run daily on a time range of yesterday. And that's how you would alert on your data ingest exceeding 50%. And then lab 23, installing the Apache app. Basically, you just go to the app catalog, click the button to install it. You have to provide it with the source category. So I think in ours, it's labs Apache, and you could either do star, or if there's a separate one for access and error. I forget, I haven't installed it in a while. Let's go ahead and just do that. So when you click to install this, yep, so this is the one for Apache access, and this is the one for Apache error. So a question, where do you go to add another panel to the existing dashboard? So that, that goes back to the original dashboard workflow. You have to write the query first and then add it to the dashboard using the button provided from the aggregates panel. Unfortunate that you cannot just click here like, oh, I want to add a new panel. And you can do that with text panels as long as you're in edit mode. So if I go to my David dashboard that I built for something else, while in edit mode, you can add title panels and text panels from over here, but these aren't the same as a query panel, a dashboard panel. To add those, you have to start with the query itself, aggregate, get it to the visualization that you want, and then you click the Add to Dashboard button, and you'll find the name of that dashboard within your list. So that's how you add another panel to an existing dashboard. All right, so I've eaten into your test taking time a little bit. Let's go over the details of that. So it's best if you can log into your own Sumo deployment to take the exam, but I don't believe it's a requirement. So in your own instance, you'll go to the same certification tab that we had navigated to find the hands-on labs. And in there, you'll just click take the exam, and that will launch the certification exam. There are 3 retries before it gets locked. But since you have a number of resources that you're available, hopefully nobody fails more than once, if at all. So for the remainder of this hour, I will be here. I'll probably just mute myself so that I'm not distracting anyone, but I'm here. Okay, so answer from Stacy. Yeah, definitely a requirement to take it in your own deployment in order to get credit for that certification. I know we've used workarounds before. I think I've been present for some of those, so maybe I had been mistaken in remembering that. But again, so click take the exam here. That will launch the certification exam, and feel free to ask questions along the way. You can go back to your hands-on labs. You can use the Sumo deployment. All resources are at your disposal while you take this test, so feel free to ask away.